Thanks, Sean. Oh, yes, I was gonna forget. Thanks, Josh. Okay, now we're recording. Welcome, everyone. Thanks for coming to the July community call. We are delighted to have Sean Fraga, who is the project director for Booksnake here. Before we dive into that demo and I give a little more space for Sean to talk about his project, we have a couple of announcements. Josh, there's a leaf blower behind me, so I'm going to give it to you first to talk about Internet Archive.
Sure. Thanks, Caitlin, and welcome folks here and watching the recording later. So the first one, or I guess the piece I'll talk about, is the Internet Archive work. I mentioned this at our annual conference. I kind of debuted it at the annual conference in Naples just about a month ago. But really, it's exciting work to say that we are working with the Internet Archive to upgrade their IIIF infrastructure. So the Internet Archive has had some IIIF capabilities. There's kind of a shim that was built about 8 years ago that allows the ability to get a IIIF manifest for image items on the Internet Archive. And it's been widely used by the people who know about it, but it was never really deeply advertised. It's been kind of hidden functionality. And so at the end of last year, we reached out to the folks at the Internet Archive and basically got a lot of support from them. They're very excited. And we have been working with folks in the community to upgrade, basically to put onto production infrastructure. The manifest generation will work for all the Internet Archive items. And that means a couple of things. So it means that we'll be upgrading to version 3.0 of all the APIs, so the image and the presentation API. And it also means that every item in the Internet Archive will get a IIIF manifest, or to a close approximation. There will be some rare items that won't have it. But basically all the AV material, all the image materials, all the Grateful Dead shows, all the live concerts, all the great TV news archive stuff, basically anything that has kind of an open streaming ability, whether that's AV or an image item, everything will have a IIIF manifest. So that will instantly kind of, I think, bump the number of items, IIIF-compliant items in the world by, I think, like an order of magnitude. Definitely hundreds of millions of images and AV items, maybe another comma after that. So this is kind of a pre-announcement of that. It's not secret work. We're doing work with the Internet Archive folks in an open public GitHub repository, but just wanted to kind of give folks a heads up, and that should be kind of the first step of that. The beta version of that new release should be happening in the coming weeks. So stuff that we're really excited about, and if you're excited, you want to help us test, or you just want to keep apprised, just let us know. Drop us a line on Slack or email us at staff@iiif.io. Yeah, and that's it on the IA front.
Great. And then just one update from me. So next month, we are not going to have a regular community call. Rather, we're planning a community sprint to clean up the awesome IIIF list. I'll put a link to that in the notes. But the IIIF awesome list is a great resource of tools and implementations and just cool stuff, but it is outdated. So we are going to work together during these different meetings in the month of August to fix broken links, add new tools, and make it a little more functional and usable. So that's all on the community calendar, and then you will all be hearing plenty from me between now and then. Okay. Anything else? No? Okay. So let's get started. I'm going to hand it over to Sean Fraga. He is the project director for Booksnake, and he's going to start us off with some demo, and then we'll have some time for Q&A and discussion after that. Okay. Thanks, Sean.
Terrific. Thank you so much, Caitlin. Thank you, Josh. Thank you, everyone, for having me. As Caitlin said, I'm Sean Fraga. I'm a historian and a digital humanities practitioner, and I'm here to talk about Booksnake, which is a new scholarly app for iPhone and iPad that we're building at the University of Southern California with support for from the National Endowment for the humanities. Booksnake runs on IIIF, and so I'm really excited to be talking with all of you today. We previewed a really early version of Booksnake, what was basically a working prototype at the IIIF conference online 2 years ago. And so I'm excited to be coming back, bring this back to the IIIF community and show you all the work we've done on Booksnake since then. So let me start out by framing the project big picture. As all of you well know, galleries, libraries, archives, and museums, GLAM institutions, have spent much of the past 30 years or so digitizing their collections and putting them online, figuring out a way to make them publicly available. These are the world's cultural treasures. They're a click away, but the interfaces for interacting with these materials were built for the desktop web. The image viewers that we use to interact with these materials rely on a mouse or a keyboard to mediate our interactions. And so you have to zoom in and out and click and drag in order to navigate them. And these viewers arbitrarily rescale digitized content to fit the screen that you have in front of you. So you can never tell how big something actually is. Booksnake is our answer to these problems. Booksnake is a new kind of image viewer, one built for an age of mobile computing. And it's an argument for a way of seeing that privileges embodied interaction with cultural heritage materials at their real world size. I want to start with a really clear summary of what Booksnake does. Booksnake transforms existing IIIF-compliant digitized archival materials into size-accurate virtual objects for interaction in physical space. And the central technical innovation here is producing dimensionally accurate virtual objects that match the size of the physical originals. And I'm going to describe more about the pipeline, how Booksnake does that work later on in my talk. So what does this look like? This transformation, size accuracy, physical space, what does this look like? This is easier to show than to describe. So I'm going to switch views here and take you through a live demo of Booksnake, how it does, and then we'll come back to the slides here and I'll talk about how Booksnake does what it does, take you through the pipeline and discuss some of our recent work with compound objects and with lists. So before I switch over to my iPad that I have connected here, could I get a search term, something that you're interested in seeing in the Library of Congress collections? This might be a major American city, a place you've lived, a place you're curious about. Castles. Okay, sure. Let's see what shows up when we search for castles. So I'm switching my screen sharing here from my computer over to my iPad. This is the main screen for Booksnake, and I'm going to take us over to the Explore tab marked by the magnifying glass in the lower right corner. And this is where eventually this will be populated by buttons for different archival catalogs. Our current partner is the Library of Congress, and this is a search box that is going to take us directly into their catalog. So I'm going to put in the search term castles and go ahead and tap search. Booksnake is loading the Library of Congress website. This is an in-app web view. So this is the exact same view that you would see if you went to the Library of Congress and ran that search term yourself on a desktop or laptop computer, on an iPad or an iPhone. The only difference here, you might notice this MIME-type image JP2 tag here. We're pre-filtering search results so that the only search results you see in Booksnake are those that are already compatible with IIIF, items that already have a IIIF manifest. And so from here, we can scroll through the available material. Looks like some notated music. Fantastic. Looks like a bit of a map here. It looks like a photo. So I'm going to start here with this this notated music. This seems to be for an opera. And I'm going to tap the add button that you see in the upper right corner here. And this is the way of adding an item to Booksnake. So what it's done here is go out to the Library of Congress website, request the item, and it's adding that in the background. I'm going to tap keep exploring here and then go back to return to the search results. We'll see what else is here. I'm going to take the opportunity here to filter on the left side. So the original format that I'm curious about, I wonder what maps there are of castles. I saw one in these search results. And so here's that filtered by maps. Newcastle is a place rather than a building, but I love a good bird's eye view map of American cities, so I'm going to add this as well. And so again, booksnake accesses the item and tells you that it's begun downloading. And this time I'm going to tap Go to Library. This is going to take us back to the library view. You can see that that first item, the notated music, has already been added. It's at the top of my library, and that map has just now downloaded in the background. And so from here, I can view either of these items. I'll start with the notated music here. We have thumbnail images of the items that I can swipe through. And then down below, all of the same metadata that you would get on the library page. All of this is constructed directly from the IIIF manifest that Library of Congress serves. The heart of Booksnake is being able to view these materials at their life size in your space. So I'm going to tap the blue View in Your Space button, and this is going to open the live camera view on this iPad. So you're going to see my laptop here, the desk that I'm working at, and Booksnake is going to insert the virtual object into the live camera view. This is augmented reality, a way of blending virtual objects into physical space. So here we are. This is the live camera view for where I am. I'm tapping here to place this content. And from here, we can flip pages. This item looks a little large to me, so that's something that we're going to investigate. But if I want to shrink it down, I can take 2 fingers and pinch in the same way that I can with a photo or something. I'm going to go back to the library view here, and let's look at this map of Newcastle, Pennsylvania. So again, all of that metadata constructed from the IIIF manifest. And again, to view in my space, I'm going to open up that live camera view. And this time I'm going to try putting it up on the bookcases here. And there it is. And once this object is pinned in space, I can move around. I can go away from it and come back, and it stays exactly where it is. And if I want to get closer to it here, I'm standing up and taking the iPad over to the extent that the cord connected to the computer is permitting this to look at different elements of this map. So let me stop the screen share of Booksnake. I'm happy to talk more about any of what you just saw. But first, I want to take you through some of the slides in order to describe how Booksnake does what it does. So Booksnake works by linking 2 existing technologies in a new way. All of you are familiar with IIIF. Booksnake uses IIIF to access and download digitized materials from online collections. These are then stored locally on the device. I want to say here that Booksnake wouldn't be possible without IIIF. And my hope with the project, beyond the application itself, is that by demonstrating a novel method for taking existing IIIF-compliant resources and transforming them for interaction in augmented reality, that this is something that will help drive wider IIIF adoption, both to new institutions and within existing institutions. So that's one side. That's how Booksnake pulls information down from the web. Then Booksnake uses RealityKit to bring digitized items into physical space. RealityKit is an Apple iOS framework. It's something that is built into every iPhone and iPad produced in the last 6 years or so at the operating system level. So it's not an app, it's not anything that you download. Instead, it's an affordance already provided by the software. We use RealityKit to create virtual objects and to manage interactions in augmented reality. So all the work of identifying surfaces, anchoring virtual objects, interpreting a user's touch gestures, all of that's built in. We stand on the shoulders of giants. It makes Booksnake, the work that we do with Booksnake, we're able to concentrate on the data management and on the front end. We're building Booksnake for iPhone and iPad first as a research project, as a way of figuring out how to do this, how to get this pipeline set up and optimized. And as the project starts to move beyond an experimental stage, we're planning to develop an Android version as well. So in linking these 2 technologies, IIIF and RealityKit, Booksnake is able to transform existing digitized cultural heritage materials for exploration in augmented reality. Here's a little bit more detail about how that pipeline works. When a user adds an item to Booksnake, as you saw me do with the Library of Congress, Booksnake reads the catalog page URL, converts that into a IIIF manifest URL, downloads and parses the manifest, and then downloads the linked digital images from the manifest. Then booksnake puts all of this information together to create a custom virtual object. So first, booksnake creates a blank virtual object that matches the item's physical dimensions and proportions. You can think of this as being similar to taking a piece of foam core and cutting it down to size. What you have at this point is a rigid plane with no content. Then booksnake applies the digital image as a texture. So it takes this JPEG and it wraps it to fit the face of the virtual plane. And this results in a custom virtual object that matches the physical original in its size, in its proportion, and its appearance. Booksnake does all of this at runtime when the user taps that blue View in My Space button. So all of this stuff is stored in the app and converted into this custom virtual object upon the user's request. And then booksnake lets you interact with the virtual object in physical space, pinning it to a flat surface so that you can explore it like you would in a library or a museum. The way that booksnake is able to do this builds on the cameras and sensors in mobile devices that allow these devices to understand themselves in space and in relation to the physical world. And booksnake uses data from cameras and sensors here to keep the virtual object stationary in physical space, even as the user and device move. The project takes its name from book snakes, those little weighted strings we use in archives. And just like book snakes hold physical materials in place, Booksnake the app holds virtual materials in place. And the effect of this, it's a little hard to convey over a Zoom call, but when you're doing this in person, you end up looking through your device at the virtual object. You're still looking at the screen, but you're looking through the device almost as though you're holding a frame, and it feels like the item is there with you. You can stand up and look down at it. You can peer at it from the edge of a table. You can get in close and follow a river or follow a road across a map. Or you can walk away and then turn back and look back at the object from across the room, still right there on the table or on the wall, wherever you left it. The important point here is that Booksnake is a content agnostic viewer for existing digitized cultural heritage materials. So I'm using a map in this example, but as you saw earlier, you can also use Booksnake to view notated music, manuscripts, correspondence, photographs, architectural plans, so forth, pretty much any IIIF-compliant digital image. And so by doing that, Booksnake brings the exploratory freedom that users associate already with viewing online collections into augmented reality. I want to briefly underline that what we're doing with Booksnake is a different approach from most humanities projects using AR or VR virtual reality. Those projects typically present a limited set of expert created or expert curated virtual content. Instead, we're using augmented reality to create a general purpose tool, something that is closer in concept and in use case to something like Mirador or OpenSea Dragon. Let's talk about metadata. Booksnake's argument is that size matters when it comes to cultural heritage materials, that size communicates important information related to the text, related to the direct content. And so we've put a lot of work to make sure that Booksnake can consistently display digitized items at their real-world physical dimensions. But this involves a bit of educated guesswork. So here's where I talk about our methods for making those guesses. The underlying issue is that, as you know, IIIF is a framework, it is not a standard. And this gives each archive the flexibility to implement IIIF as best fits their collections, their needs, and their priorities. But it also means that Booksnake, as downstream from those archives, can't count on any consistency in how those archives format or present dimensional metadata. So, for example, the bird's eye view map on Los Angeles that I was showing on my previous slide, or those two example items earlier, all of those are held by the Library of Congress, one of our partners here. Library of Congress provides dimensional data in the item record where that's available, but it doesn't provide that in the IIIF manifest, which means that that data isn't computer readable because it simply isn't there. In a second, I'm going to talk about how we worked around that, but I want to focus on comparisons for the moment. We're also working with the Huntington Library, which does include dimensional data in their IIIF manifests, at least when it's available, which is much of the time. But that data is given as a text string in the physical description field. And because of that, the metadata isn't computer readable. And a third example, the David Rumsey map collection does include computer-readable dimensional metadata in their item records and in their IIIF manifests. It's given as a number, a numeric value, one field for height, one field for width. And so because of that, the Rumsey collection, I expect, will be much easier to build a technical bridge with than it was to build with Library of Congress. And more broadly, because of this challenge, I'm planning that we will need to adapt Booksnake at this point on an archive by archive basis. And one of our major research areas is looking for ways to improve how Booksnake identifies, ingests, and interprets different types of dimensional metadata, different ways that metadata is presented, whether it's as a text string or as numeric values. So let's go back to Library of Congress. If Library of Congress doesn't provide dimensional metadata, how does Booksnake create life-size virtual objects? We use the pixel dimensions of digital images. This probably sounds wildly wrong to a lot of you, especially if you've worked in digitization, so I want to pull back and explain how this works. The digitization process at any institution involves three pieces of metadata. First, we have the item's physical dimensions, its width and its height, measured in inches or centimeters. And second, the digitization resolution. This varies a lot depending on the kind of item, the reason for digitization, the standards you're following. But this is usually between 300 and 600 ppi, again, depending on item type. And multiplying those two values together produces the item's pixel dimensions, its width and height in pixels. This is a one-way street. You can take physical dimensions and resolution to get pixel dimensions, but under ordinary circumstances, if all you have are pixel dimensions, there's no way back to physical dimensions. And so Booksnake needs either an item's physical dimensions or both its digitization resolution and pixel dimensions. So after a lot of research and troubleshooting with Library of Congress, we learned that they follow the Federal Agency Digitization Guidelines Initiative standards, the FADGI standards. And those specify a target digitization resolution for different item types. Here's what you need to digitize books at, here's what you need to digitize slides at, here's what you need to digitize newspapers at, across different performance levels. We ended up building a reference table with this information. So now when Booksnake imports an item from Library of Congress, it consults the IIIF manifest to determine the item type. Then it goes to the reference table and looks up the corresponding resolution, and then combines that with the pixel dimensions in order to derive the physical dimensions. It's a little more complicated than that because of how Library of Congress stores different digitized materials, but that's the broad overview. And this process is similar to the IIIF physical dimension service, which some of you might be familiar with, except that it's running client-side on device and it's customized to Library of Congress collections. I'm also not aware of any archive that's actually implemented the physical dimension service. I've done some research into this. I'm really curious about this. So if you happen to know of someone out there who's using the IIIF physical dimension service, please get in touch. I'd be really curious to know more. So, as all of this suggests, determining an item's physical dimensions is a seemingly simple problem that can quickly become complicated. And so again, developing a robust method for parsing different types of dimensional metadata is really a key research area for us, because doing so will allow us to expand the range of archives, collections, and materials with which Booksnake is compatible. I want to tell you a little bit about our current research. Last summer, Booksnake received an NEH Digital Humanities Advancement Grant, which we've been using to build support for compound objects. Compound objects, as many of you know, are items that contain multiple images within a single catalog record. So books, newspapers, magazines, periodicals, the music that we saw earlier. And for a viewer like Booksnake, they present both a data management problem. How do you download all of this information, keep it organized, keep it optimized, and then also an interface problem. How do you bring different images into augmented reality and make them easy to interact with from a user perspective? We've been using the Chronicling America collection of digitized historical newspapers as a testbed, as a place to work out some of these questions and problems. And we're currently in the process of extending that work to other domains, to other objects within Library of Congress collections. And I want to say here that I'm particularly proud of the work our developers did to get the page turn animation working. That took most of the year, and I think it's worth it. We're also thinking ahead to how Booksnake can be most useful in a variety of learning contexts. Part of that is building different curation capabilities that fit the model of having an app that's running on a personal device, that one-to-one relationship we have with our phones or tablets. Booksnake lets you assemble materials from different collections, different institutions, into a list, like a playlist of songs, and then share that list with others. So you might imagine doing this as a way of sharing primary sources with students as part of a class assignment. The screenshot suggests that use case. Here's a list of things for you to look at before our next class, or here's a list of things that I looked at, that we looked at together as part of my lecture today. Or you might imagine using a Booksnake list to share a collection of primary sources with other kinds of audiences. You could use a Booksnake list to share sources in a journal article or a book chapter or a conference presentation with fellow scholars. Or you could use a Booksnake list to share materials with public audiences by pairing a Booksnake list with a museum exhibit or with a podcast episode. Finally, why all of this matters? Why spend, at this point, 3 years building an augmented reality viewer for IIIF materials? I want to close with some questions about interface that I encountered as I was starting this project from Joanna Drucker. She asks, what kind of interface exists after the screen goes away? A handheld device that conjures the data world into view? I touch the surface of my desk and it opens to the library of the world? My walls are display points, capable of offering the inventory of masterworks from the world's museums and collections into view? These questions all point towards spatial computing, towards a world beyond, as she suggests here, screens and monitors. And this is what Booksnake is building towards. We're building Booksnake for the containers that we have today, for iPads and iPhones, for tablets and phones, for these screens and for these hardware affordances. But we're also very excited about Apple's recently announced Vision Pro and the idea of spatial computing and how cultural heritage materials might fit into that, the opportunities that spatial computing might offer for closer and richer engagement with digitized materials. So as a viewer with a spatial interface, Booksnake is a way of virtualizing the reading room experience, the museum experience. Again, I'm trained as a historian. Booksnake comes out of my love for archival research and the time that I've been able to spend in reading rooms. And by virtualizing the reading room experience, Booksnake is also a way of democratizing it, of making embodied interaction with cultural heritage materials more accessible to more people in more places. In short, Booksnake is a way of mobilizing the unique capabilities of phones and tablets, again, those sensors, those cameras to understand themselves in space, towards a spatial interface for humanities research, for cultural heritage materials, an interface that is radically new, but that also feels deeply familiar. Booksnake is a collaborative, multidisciplinary project. It's a really weird project within the university. It exists thanks to the work and the creativity of these people. And I particularly want to recognize our developers, Christy, Henry, Michael, and Zach, all of whom regularly do the impossible. I also want to acknowledge our advisory board members, Rebecca Corbett, Louise Smith, and Philip Ethington here at USC, as well as Tom Scheinfeld at the University of Connecticut, and our educator and technical partners under our current NEH grant here at USC, at California State University, San Marcos, at the Huntington Library, Museum, and Botanical Gardens, and at the Library of Congress. Together, we're working to build the future of immersive cultural heritage, and we want your help. You can scan this QR code to visit the Booksnake website at booksnake.app. You can sign up for our email list. We'll let you know when Booksnake launches as a free public beta this fall that you can download and run on your own devices, your own iPhones and iPads. We'll have access to Library of Congress collections with more archives on the way. As part of our NEH grant, Booksnake's source code will be available on GitHub. We're also building support for the IIIF version 3.0 APIs, and I'm putting together funding for us to release a Swift library on GitHub for those APIs to support other projects, other future work with IIIF and iOS. Also, speaking to the audience here on this call or those watching the recording later, if you're interested or at all curious about bringing your institution's IIIF-compliant collections into Booksnake, please email me, please get in touch. I would love to talk more with you, and I'll drop my email address here in the chat and add it to the Google Doc. Ultimately, we're building Booksnake to enable digital accessibility and to connect more people with primary sources at a moment when so many people are infatuated with the potential and the perils of generative AI. Booksnake is a way of turning our attention back to real things and to the place those things have in the real world. So that's Booksnake. Thank you so much, and I look forward to your questions. I'm also going to take a chance here to look at the chat, which I haven't been focusing on during the presentation.
Thanks, Sean. Yeah, the chat was very active and there's a lot of questions in there, some of which we've probably answered. So I'm wondering if anyone has a question and they'd like to kind of virtually raise their hand and talk, since we have a small group. Otherwise, I will try to read through them.
Maybe I have a question that maybe gets us started, and people can, re-ask some of the questions from the chat too. But I guess I have a question that's in two parts. And one is maybe kind of a question about like technical capability in ARKit. And the other is like whether this is something you've thought about from the design and functionality side for Booksnake. So it's funny. I mean, I've seen the map on a desk example, I think, when there was a previous lightning talk, but I'd never seen you pin something to a wall before. And for some reason that was sort of a neat paradigm shift. And then that sort of brought to mind, basically, I guess my question is like both technically and design wise, can you pin multiple items? Is this a one at a time interaction design on purpose, or technically, like in ARKit, could you pin like multiple ones to a space? And then if you can, like, is that something that you have any desire to do in something like Booksnake, or does that open a can of worms that you basically don't want to approach, which would be totally fair?
Yeah, fantastic question. It opens a can of worms that we're really excited to approach. I think multiple objects is a use case. You're not the first person to ask about this. It's something I'm really excited about. And last month finalized another NEH grant application to build exactly this capability. We have a strong technical foundation for that already, because the way Booksnake builds compound objects is by assembling multiple individual virtual objects, one for each page, into something that supports the illusion of a cohesive whole. So each page that you saw, the front and the back page, each of those are technically, well, not just technically, they are individual virtual objects, but they've been constrained in how the user can interact with them, so that you get that codex experience of turning pages. The questions then are how you manage the interactions with multiple items, how you place, select, move multiple items in space, if there's a way maybe to save a workspace after you've laid out multiple different items, or somehow save and convey that to other users in the way that you can with a list. So I see multiple objects as being one of the really big, exciting next development questions. Mirador, of course, is based on the idea of comparing objects from different institutions, and bringing multiple objects into Booksnake would be a way of extending that capability into physical space. So yeah, something that we're excited about, something we're thinking about, hoping for that NEH grant. This is a big project and something that I expect would take a year or two of work with developers. I don't think I have anything else to say about multiple objects at this point. Just that it's an exciting area of potential research for us, for all of the reasons that you outlined.
That's great. Thank you.
Okay. Joe?
So you're developing this with RealityKit, you said, which is Apple dependent. I was just curious about whether you'd explored the potential for other platforms. And sort of linked to that, I was curious, obviously you're creating an app and it's within this app, but certain aspects of your development will speak to the IIIF standard as a standard. So I have seen other examples of people playing with this augmented reality, like some of the stuff Memosine have done for a while. And they put one of our paintings up in our library virtually a little while ago. So I was curious how your development might be feeding to help other people do similar things, or how other people's development are helping you do what you're doing. So that kind of speaks to sort of both aspects of that question.
Okay, so two questions there. One about the development choice of using Apple platforms, and then also about how this is going to feed back into the broader IIIF ecosystem and community. Yeah, good questions. We started with Apple's platforms because Booksnake is inherently a mobile experience. It uses the cameras and the sensors that are uniquely available in mobile devices in order to understand space and in order to bring those virtual objects into physical space. There isn't a way to do this on laptops or on desktops. They don't have the rear cameras, and more importantly, they don't have the sensors to understand their orientation, their position, how a user is holding them. So knowing that this was going to start from mobile, there are three possible major development paths. One is Apple, one is to develop for Android using AR Core, and one is to make this as a web app using WebXR as a cross-platform mixed reality AR/VR toolkit. So of those, we chose Apple because Apple offers a really tight integration between hardware and software, and something that, how do I put this? They haven't been explicit about this, but a long-term commitment to developing and supporting the tools for mixed reality development. This is easier to see now that the Vision Pro headset has been announced than it was to see 3 years ago. But in terms of their developer communications, the APIs they had available, the frameworks and the way that they were supporting them, it was clear that this was an area where they were investing. I think it matters to that point that ARKit and RealityKit are something that are supported on devices for the past 5 or 6 years. And so that tight integration between hardware and software is something that helped make this kind of development easier. AR development is really messy. It's messy because it involves real world data that is always changing under variable conditions, lighting conditions, how the user is holding the device, the kinds of sensors and things that you're getting in. And because of that, the Apple platform, gave us a way of outsourcing all of that, or most of that, to the system software. I said earlier, we stand on the shoulders of giants, and part of that is because RealityKit has made it possible to do this in a way that is, from our development perspective, relatively straightforward. I'm looking ahead to AR Core and to Google and to Android. Part of the problem with developing for that ecosystem is, first of all, there is an enormous amount of variation in terms of hardware, in terms of the resolution and size of screens, in terms of processor power, in terms of memory, and that fragmentation was going to make it really difficult to develop something that offered a cohesive experience across devices. We're also a small team. This is me and at most right now 4 and 2 we're bringing on. And I started this project as a postdoc, and it didn't seem feasible to get one of every Android device and test them out. The other reason that we moved away from Android is that so in the United States and globally, there's sort of a duopoly between Apple and Android. In the mobile market, in terms of mobile phones, they each have about 50%. In the US, it's 60% Apple, 40% for Android. That figure varies depending on geography and the rest of the world. But when it comes to tablets, there isn't much competition with the iPad. And screen size really matters with Booksnake. Your screen is the window that you're looking through. So Booksnake is great on a phone. I use it on my phone all the time, but it's fantastic on an iPad for a completely different reason, because you can see more of your space and you can see more of the item. And so for those reasons, those hardware and software sort of development pipeline reasons, that's why we went with Apple over Android. As to WebXR, when we started the project, WebXR wasn't stable enough for this kind of work. At this point, it has become stable, but it lacks the kind of features that we're interested in for this project. And I think particularly would constrain us in terms of things like multiple objects. I'm also not sure from a technical perspective how we might do something like compound objects in WebXR. But beyond Booksnake, although I'm personally bullish on the Apple ecosystem, I would love if this project inspired someone else to go out and figure out a way of doing this in terms of WebXR or in terms of Android. And if there are people out there who want to collaborate on those kinds of projects, taking Booksnake into new development areas, I'm all ears. And that takes me to your second question about what Booksnake has to offer back to the IIIF community and the ecosystem. Part of this is source code and software frameworks, the ways that we've built to do what Booksnake does. As I said in the talk, Booksnake source code will be publicly available on GitHub by the end of our NEH grant period. I'm also putting together funding to share the Swift library, the iOS library for IIIF version 3.0 APIs that we're building in order to bring in the USC digital library into Booksnake. We're going to standardize that and I hope to make that publicly available on GitHub as well. And beyond specific software frameworks, there's the technical and conceptual work we're doing with metadata. A consistent question, this was true when we presented Booksnake at the IIIF meeting 2 years ago, when I presented at the ACH, is how you get real world objects sized to their real world physical dimensions back out of the digitization pipeline. And so the work, for example, that we've done with Library of Congress of building this reference table to translate their pixel dimensions into physical dimensions. Yes, we've implemented that within Booksnake, but that's something that you could take that and use it as the basis for a WebXR viewer or a web-only viewer, a flat screen viewer that, for whatever reason, emphasizes digital images at their real-world size. And beyond those sort of technical contributions, AR is an exciting interface. It's new for a lot of people. They didn't know that their phones or tablets could do this. I started with AR because I was interested in it as a space of examining finely detailed, intricate objects that, for whatever reason, you don't have access to personally. And a lot of the AR demos 3 years ago tended to be things like the solar system or a human heart or a jet engine that you could look at as a 3D model in your space. And I thought, I know people who have highly detailed objects that they want to examine from an embodied point of view. I'm part of that community. This is historians, this is humanists. And so I think that the ability of Booksnake to demonstrate that cultural heritage materials, including this enormous, culturally significant and expanding body of digitized materials, can be transformed for virtual interaction. I hope that it inspires other projects in a similar vein. Matthias?
Finding the unmute button is always the biggest challenge. Thank you, Sean, for your presentation. I have a question regarding your team, especially the advisory board. So I went through your pages and it's a bunch of people involved in this project. And you mentioned also it's running for 3 years already. My question is, what kind of feedback and requirements did you get from the advisory board in terms of the concept for what you're doing? So just green lights, everything okay, go for it? Or do you face some challenges or some stretch goals, or do you have concerns whether your concept is really convincing to everybody not attending this call?
I think the biggest debate that I've had with the advisory board, I'm debating whether this is something I should draw out into public. I'm making it sound bigger than it actually is about zooming with digitized materials. My original concept with Booksnake is that size accuracy was really important, that when you bring a digitized item into the real world, it should be at its real world size, and that the only way that you would have of interacting with it was as if it were actually there. And the advisory board, particularly Phil Ethington, early on pushed me to include capabilities for zooming so that you could pinch to expand, you could pinch to shrink. And Phil's point is that one of the affordances of digital projects is that you can interact with items in a way that isn't possible in the physical world. I take his point about that. I think it's also an important accessibility feature. If you are using Booksnake and if for some reason your mobility is limited, you can get that sense of how an object sits in the world, but you can also zoom in order to focus in on certain details. So that was sort of a philosophical debate. I think the way that we resolved it was by building in UI and UX affordances that help to convey to the user when they are zooming that they are taking the item away from its real world size. So as you may have seen during the demo, first when you start an AR session, the size of the target, the red lines, indicate how large something is going to be. So if you're bringing in a small object, you're going to get a small target. If you're bringing a large object, you're going to get a large target. And that helps you figure out where to place it. And at another level, sort of subtly communicates, this is the size of the object. And then when you zoom, there's a little pop-up and it shows you how much above or below 100% you're zooming the item. And that says, okay, yeah, this is bigger now. It's 200%. And so this is twice as large as it actually is. And so I felt it was important to always find a way home. I think that's been the biggest conceptual question. We've talked recently with the advisory board about data collection and some of the strictures unique to publishing an app like this through an app store managed by a third party, as opposed to just making it directly available on the web. And then, of course, we're always talking about longevity and long-term funding and how to support a project like this, especially because the app itself will be free to end users.
May I add a follow-up? I see no hand, so I take
Please.
this as my background image is kind of similar to your scenario. So you have lots of pages from different libraries and you shuffle them around. And this is also what Josh has asked already. So how to deal with multiple objects. In the chat, we had the question whether you go into the direction of Apple Vision Pro, and I was mocking a little bit. So do you know the scene from The Matrix where the virtual shelves with all the guns are flying towards Keanu Reeves, etc.? So just imagine this as the Library of Congress coming towards you, and you pull the item. So you need some kind of wow factor in your application. You have it to a certain extent already. So given you have an old wooden table that makes really sense, you feel like an antiquary opening the treasures from the past. But I would like to urge you to add a little bit more magic to the game and more performance and more, well, you do not have to replicate the real world and turning the pages very slowly, because real books are kind of sacred and you have to be very careful. So there are much more user interface paradigms that are much more powerful than just replicating a virtual object as it would be there. It's cool stuff already, but I urge you to think a little bit more, well, how's it called, to push the envelope or cross the edge of the whatever idiom suits you right now.
Yeah, thanks for that. And I see Josh in the chat has asked about the reliance on skeuomorphism of both with the size of the objects, and then to your point with how the pages of a virtual book should turn. I think you're right. I think that we could have an interesting and very robust debate about what the user interface and user affordances should be with virtual objects, how closely they should resemble the physical world or depart from it, how much we want that kind of matrix sense. I'm coming at this from the perspective of a historian, and I think that has made me very conservative in terms of how we present these virtual objects. I want them to closely resemble the physical originals, in part because Booksnake is about that. The model for Booksnake is the reading room experience. But this is not the only way that these objects could be presented. And again, the source code is going to be public, and I'm curious to see sort of what other projects we start to see in this space. And very briefly to the question about developing for Apple Vision Pro, I would love to. We're also a small team, and the funding that we have presently is really focused under the NIH grant on compound objects, on getting out the public beta, So if I'm able to find internal funding here at USC or other sort of exploratory funding for that, it's something we're looking at, right? It's a new spatial paradigm for computing. And I think that the work that we've done for these containers for phones and tablets could translate really nicely into something like a headset. It frees up your hands. It makes the interaction with virtual objects, with these cultural heritage materials, potentially much more fluid, immersive, and engaging. So I'm excited about it, but I'm also, as ever, thinking about the money and the larger trajectory of the project. We can do anything, but we can't do everything, as one of the former directors of the Getty used to say.
If you don't take the Matrix, what about The Name of the Rose with Sean Connery by Umberto Eco for a wonderful old Mediterranean library? Final comment.
I haven't seen that. I'm going to have to check
you
that out.
should, you should.
The Name of the Rose. Okay.
Yes.
Matthew?
Yeah, thank you for your presentation. And since The Name of the Rose came up, I had a kind of medieval question, just knowing another project at USC that's looking at 15th century manuscripts, and I've seen their presentation. They're really in a virtual reality space with those headsets. But I wonder, since you talked about kind of the future of Apple Pro, or I don't know anything about it, but there's kind of another team working on a similar problem, and I wonder how that unfolds, where you are as a department, or if you've talked to that team, because they're taking that other view that you said, a really curated object, whereas you're taking entire libraries.
Yes, yeah, thank you so much for that question and for mentioning Lynn Dodd and Sabina Zano's work, my colleagues here at USC. For those of you who don't know, their project is to reproduce, I believe it's a 15th century book of hours in VR. So you have both the model of the book itself, and it's presented within a virtual space, a religious space, a church, that is similar to the space where the item might have originally been used. And I think that there are two important differences between these projects. I'm biased here as the project director for Booksnake, but if I step outside of that role, I think, again, there's an interesting debate about how these objects should be presented and what the point of presenting them is. One big difference is that Booksnake is an AR project. It blends virtual objects into physical space. It's like having a reading room anywhere. Lynn and Sabina's project is a VR project. It's immersive. You put on a headset and you're transported into this church. And I think that there's power to that. I also think that in terms of development cost, a lot of time and effort goes into modeling not just the object, but modeling the environment that it's in as well. And the second difference is on the back end. In Booksnake, content agnostic viewer for existing materials. Booksnake is basically a bunch of blank pages that you can texture with any JPEG that you want, served up through IIIF. And so it's a pipeline, right, for bringing down these materials and presenting them in virtual space. Lynn and Sabina's project takes a different approach. Instead, I believe I'm probably getting into territory that I don't fully know the details of. My understanding is that their project, instead, that those virtual objects, the books, the manuscripts that they're working with, are constructed manually from images that are downloaded from existing repositories. And so those two differences in terms of how these projects are actually built out, those technical differences, I think are a useful source of debate. I'm seeing a question in the chat here about whether you can stream content to this kind of virtual space or whether you have to download it. At this point, the Apple's Reality Kit doesn't provide a way for calling images remotely while you are in an AR session. So put another way, the only way that we have within Reality Kit of applying an image onto a virtual plane is to do it from an image that is already stored locally on the device. And that informed the UX of having to add an item to your library before you can view it in virtual space.
Just as a follow-up,
yeah.
What resolution did you decide to download then?
That's a very good question. Library of Congress by default serves their IIIF-compliant images at 25% of the full size that's stored on the server. That is not the whole answer, because depending on the collection, their images are also downscaled or maybe downscaled from the original. When we download items to Booksnake from Library of Congress, we request them at 50% of the size stored on the server. And what we found in our initial testing is that with 25%, you still get visible pixelation in virtual objects, and that goes away by 50%. 50 is probably a little more than we actually need. One of the optimization things that I've been thinking about to talk with our developers with compound objects is whether we look into changing the size of the image requested depending on the item type. So maybe you really want a highly detailed map. Maybe if you're downloading a 300-page manuscript book that doesn't have illustrations, you can get away with a 40% or a 30% image size. I'll say also that the way that IIIF constructs URLs, image request URLs, makes it easy for us to do that, to find the 25% value and change it to 50%.
Is working with a percentage a bit dangerous in the world of people creating bigger and bigger images? I mean, I'm working in the National Gallery in London, and some of our paintings have been digitized at much higher resolutions than others. So simply a straight 50% request could get you very varied sizes of images.
Yeah, I think this is part of the reason that we, at this point, will need to build technical links on a collection by collection basis, because every collection, every institution is different in terms of how they process and store materials and what they are serving. So a 50% resolution for Library of Congress may be completely inappropriate for your institution. And the nice thing about software development is that we can customize that on an institution by institution basis.
Okay. Thanks.
I'm seeing in the chat, how long does it take to load a IIIF book with 1,000 pages? Do you load all of the images up front? Yes and no. Booksnake downloads all of the images. They're all stored locally. When they're brought into AR space, Booksnake only loads a maximum of 4 images. So whatever spread you're looking at, whatever 2 pages you're looking at. And then when you turn the page, Booksnake loads what are either the next 2 or previous 2 images, depending on the direction of the page turn. So you get the 2 images you're looking at, and then the next 2 images. And then once that page turn has completed, it discards the previous images. So those other images, remain on the device, but they aren't brought into AR space until the user reaches that point of the document.
I was just curious, given that example there, do you have any warnings in the app if you might be running out of space if you hit a manifest that's 1,000 pages?
We don't have any warnings in the app about space. I'm thinking through how to answer this question. I think at this point, people are used to managing storage on mobile devices. They're used to the size of their music library, their photo library, and Booksnake fits into that. This is one of the questions that I think will become particularly important as we start to scale, as we start to see how people are using this in the real world. The warnings that we are thinking about have to do with resolution. You mentioned how your institution digitizes items at a very large size, and I'm grateful for that, for the ability to support the future creation of virtual objects. Institutions with older collections or collections digitized, longer ago, may not be able to support that kind of resolution. And we haven't hit this question yet in Booksnake, but I anticipate that at some point we will have an object whose physical dimensions are much larger than the JPEG, the maximum resolution JPEG that the institution is providing can support. And at that point, we're going to get visible pixelation. So the kind of warning that we want to present there is to the user saying, hey, we're going to show you this object. For this reason, it's going to look unrealistic.
So we're at 2 after the hour. So unfortunately, I have to wrap us up here. But Sean, if you'll put your email in the notes document, you should be able to take questions offline as well. So thank you so much, and thank you all for joining.
Thank you, everyone.
Thanks.